Okay, are you guys ready? We're gonna talk about, types of energy today. Okay, and let me get this screen up here for us. I think I'm gonna try this right here. Let's try this. I'm not sure if it'll work or not. Uh-oh, let's go back here. Yeah, uh-oh, Mr. Hughes. Okay. Okay. Let's try it one more time here. Okay, so we're going to talk about types of energy, but we're not going to do it that way. We're going to do it that way right there. Okay, so types of energy. Can anybody think of two types of energy that we talked about before?
Sun and water. No,
Sun and water. Okay, but I'm talking about
electric.
electric. Okay, so let's go on here. Look here. Have you ever heard this right here? You remember we said anything that's in motion that has some kind of energy? Okay, that's the tiny energy we're talking about here. So, kinetic energy, that's the one kind of energy. And kinetic energy is energy something has because it's moving. Okay, see this guy here, he's moving. What's this right here? A cheetah, and anybody know how fast those have been known to run?
They're like the fastest thing in the world.
Like 60, 70 miles an hour, literally. The only thing is they can't run for a very long period of time.
But they could die.
Huh?
If they run too much.
They could die, yes, they could die. Okay, so kinetic energy is something has because it's moving, the runner and the cheetah. And the bigger the object, or the faster it's moving, the more kinetic energy it has. Okay, in other words, a bus full of people, say, that's driving 70 miles down the highway is going to have more kinetic energy than, say, someone in a little Kia Soul or something. You know, those are really small cars going 70 miles an hour. The bus is going to have more kinetic energy because it's bigger. Basically. Okay, now remember, molecules and atoms are constantly moving, even at that table that you're sitting at right now, or if you're at home, wherever you're sitting there, the solid stuff near you, the molecules in that are moving. They're just moving so slowly you don't realize it. Okay, so molecules and atoms are constantly moving, even if you can't see them. Okay, so there's always kinetic energy around us, right?
Yeah.
And look here, Mr. Hughes is moving his hands, I'm moving my face, I'm walking. I am emitting kinetic energy right now. Okay, so there's one type of energy, kinetic energy, and then there's a second type of energy, and it's called potential energy. Okay, look here, this guy's got these barbells above his head, right? Barbells above his head. And as long as he's got those up there, these barbells have potential energy. So what is potential energy? Potential energy is the energy that's stored in an object. Okay, sometimes the energy is stored based on where the object is located. When you lift an object, I'm going to lift this ball right here. I've got this ball. The ball has potential energy. Now once I drop it, it converts to kinetic energy, right? Okay, so potential, sometimes the energy is stored based on where the object is located. When you lift an object, just like I did, you store gravitational potential energy, because whenever I lifted this up right here, it was gravity, it's gravity that's pulling this ball down when I let go of it, okay? So that's what they mean by gravitational potential energy. To get that energy back, you would have to release the object and let it fall, which I did twice there, right? And that's gravitational potential energy. Okay, and that's energy stored. So anything that's in motion, that's kinetic energy. Is that correct? Any energy that's stored is going to be potential energy. In this case, gravitational potential energy. Okay, so let's look at potential energy a little bit more. So potential energy is energy that's stored in an object. That's what we just said. For example, when you hang something from a spring and the spring stretches, you're storing elastic potential energy, okay? This is a spring, and you hang something on it, like if you're like, you ever go to the grocery store and your parents go through the produce section and you got these little scales things with little round plates on them, and they just put like bananas or oranges or whatever, fruit, vegetables, and it pulls the spring down on the weight and it gives the weight, right? Okay, so, and that is called elastic potential energy. Okay, because it's pulling down, and when you take the vegetables or the fruits off, the spring goes back up. Okay, so to get the energy back, you would release the object and let the spring return to normal length. Okay, so let's look at potential energy. So there's also potential energy. When energy is stored in chemical substances, it's called chemical potential energy. So we've got gravitational potential energy, which is what I got here. I dropped the ball, and the gravity pulls it down. Close that door, please. Okay, that's gravitational potential energy. Right here, gravity's going to pull it down if I drop it. And then you have the spring, like you find at the grocery store in the produce section, where you weigh vegetables or fruits. And that's called elastic potential energy. And then you have chemical potential energy, and to release this energy, a chemical reaction must occur. Okay? Okay, for example, in this case right here, one thing is if you have fireworks, what are fireworks made out of? Chemicals, right?
Gunpowder.
Huh? Well, gunpowder and other things, right? Other elements. That's how you get your different colors and so on. Those are different elements that you use to get those. So when you light the fuse, we're talking about chemical energy. When you light the fuse and the heat sets a chemical reaction off, okay? So that'd be a good thing. Fireworks would be a good example of chemical potential energy, okay? And also, if your parents are in the military and they shoot artillery out of Fort Sill, same principle, gunpowder, and it causes a big round to shoot out of the tube. That's chemical potential energy that's being set off, and that becomes kinetic energy once it's set off, right? Okay, so, and then you have electromagnetic energy, and that's the energy of the electromagnetic radiation such as sunlight, radio waves, microwaves, that's stored in the electric and magnetic fields. And this energy can be absorbed by an object, okay? So, electromagnetic energy. And that's the energy of electromagnetic radiation. Okay? And then also you have microwaves, and then you have electric and magnetic fields. Okay, so electromagnetic energy. Okay, so we talked about kinetic energy, which is energy of motion. We talked about three kinds of, or actually several kinds of potential energy. We have gravitational potential, elastic potential, chemical potential, and electromagnetic radiation potential energy, right? Okay, well, we have another kind of energy. What's this lady putting in the oven?
Cake.
A cake. Mm-hmm. Or actually, she's taking it out because look, she's got her gloves on, and the cake has risen. So she's taking it out of the oven. So thermal energy is a portion of an object's average potential and kinetic energy, depending on what substance it is, okay? So thermal energy is responsible for the objects having a measurable temperature. We talked about that last year. Okay, so heat is the energy that's transferred between two objects that are at different initial temperatures, okay? So thermal energy is the portion of an object's average potential and kinetic energies per atom or molecule, okay? Depending on the substance, right? And depending on what the substance is, there'll be different temperatures. Okay, so look at another one here. conversion of energy, what are these things right here?
What
This
is
is wind energy, right? These are the fans that turn. Okay, so a wind turbine uses the wind as its source of energy. The wind actually has kinetic energy. The wind's moving, so it's kinetic energy, right? So, so the wind has kinetic energy since it's moving, that the turbine converts to electromagnetic energy. So it takes that kinetic energy from the wind, converts it to, turns the turbine, and the turbine converts to electromagnetic energy. And then the faster the wind is moving, the more energy the turbine can convert, okay? And you gotta remember that types of energy are different from sources of the sources of energy, okay? So this electromagnetic energy in this case is brought about by kinetic energy from the wind, okay? Okay, let's take it, let's answer this question here. So you should have your document up. Everybody got your document up? Scroll down to where you see, this is number 19.
Unless someone's called quiz math.
69, 70.
Huh? No.
69.
You should have your presentation slide, chemical reactions presentation slide. It should be pretty close to about 70 on your copy. Should be 69, 70, 71. You found yours? Are you there? Good. You there? Terry, you there? Jaleel? You
What was
need
it
to get
called?
there
Again?
quickly.
Chemical reaction
Chemical reaction.
presentation.
Yeah. Okay, are we ready?
Yes.
Are you there? Jaleel?
I'm opening with Cammy.
Okay, good. You got it open with Cammy so you can mark your answers? You can either type an X beside the answer, or you can highlight the answer. There's a markup tool there where you can highlight the answer, or you can use that drawing tool and you can circle the answer. Okay? Get some water here. Okay, we're ready for number one here. Are you there? You came me up?
We're number 19.
Yes, number 19. Okay, so let's look at the question here. So which type of energy is best illustrated by a bee moving very quickly? So they're just flapping those wings so fast you can't see them. Is that kinetic energy or chemical potential energy? Mark your answer. You can't choose C, you choose A or B. Which type of energy is best illustrated by a bee moving very quickly? Kinetic energy or chemical potential energy? Mark your answer. A or B. You can't choose C. Got an answer? Let's see what you've learned here in the last few minutes. Everybody there?
No.
Okay. Mr. Hughes will take another sip of water, man.
The thing says this document has been turned in order to,
Okay, let's look right here. Okay, so you want to unsubmit it. Yeah, just unsubmit it, because I got it grade already, so just unsubmit it, and you unsubmitted yours, right? Yeah, if you're at home and you have a CAMI document that you submitted to me, and you turned it in, and then I sent it back to you, maybe returned it, you should have a choice in that CAMI document to unsubmit, and then you can work on that document, okay? So don't worry about that. Once I got your grade recorded, you can just click unsubmit on that document and reuse it over and over during our lessons, okay? And if you have questions about that, if you're at home, email me, call me.
You said it could only be A or B.
It's only A or B, kinetic or chemical. Okay, I'm gonna go to number 20 here. Okay, look at number 20. Which type of energy is best illustrated by calories in food? Okay, you eat food because you're hungry. Does that give you chemical potential energy or electromagnetic energy? B or C? You can't choose A. What kind of energy does that give you? Does that give you chemical potential energy, or does that give you electromagnetic energy? B or C, can't choose A. Everyone have an answer? If you're at home and I'm going too fast for you, stop the video, pause the video, and you can go back and search, and then come back to the question, answer the question.
Oh,
Okay,
I got
you're not in any big hurry. Okay, so I'm gonna go to 21. Okay, which type of energy is best illustrated by a waterfall? Now think about this waterfall being used to turn a turbine. Okay, now you're using the waterfall. Is that kinetic energy or is that electromagnetic energy? The water itself. You're using water to turn the turbine. Is the water kinetic energy or is it electromagnetic energy? Be careful with that one. Got your answer marked?
Which ones can it be?
It can be A or C. Can't choose B. A or C, kinetic or electromagnetic. Now we're talking about the waterfall being used to turn the turbine. Okay, not the turbine, but we're talking about the waterfall to turn the turbine. What kind of energy is that? Is that kinetic energy or is that electromagnetic energy? The water. Be careful with that one. Okay. Anybody need more time? I'm gonna move on. I'm not sure if that's the last question. We do have a number 22. Okay, so which type of energy is best illustrated by burning fossil fuels to release energy? Okay, you're burning fossil fuels. Think of, actually, you can think similarly of the fireworks scenario as well, okay? Because it takes extreme heat to burn those fossil fuels, right? So is that kinetic potential energy or is that electromagnetic energy? B or C? Can't choose A. Which type of energy is best illustrated by burning fossil fuels to release energy? Would that be chemical potential energy or would that be electromagnetic energy? Mark your answer. That should be an easy one. Okay. Anybody need more time? I'm moving on here. Okay, so which type of energy is transferred between objects that are different temperatures? What type of energy is transferred between objects that are different temperatures? Is that heat or is that electromagnetic energy? Heat or electromagnetic energy? Can't choose B. Can't choose B. Which type of energy is transferred between objects that are different temperatures? Is that called heat or is that called electromagnetic energy? Mark your answer, A or C. Everybody have an answer?
What was it again?
Which type of energy is transferred between objects that are different temperatures? Is that called heat or is that called electromagnetic energy? Mark your answer. Everybody got an answer?
Mm-hmm.
Okay, look right here. Energy can be created from nothing as part of a chemical reaction. Be careful. Energy can be created from nothing as part of a chemical reaction. Is that a true statement or a false statement? Good question. You got an answer? Anyone need more time? Okay. Okay, so we're going to stop right there for the time being. Actually, if you're home, I want you to be sure you have all those answers and submit the document to me, because I'm going to take a grade from those questions that we just went over. So I'm going to take a grade for the day. So if you're at home, be sure to turn that document in to me. You can, in Cami, you just click turn in, and it'll come to Mr. Hughes. Okay, that's all we're gonna talk about for the day.
So we start that number